Example 4 is a combination of transformations and a reflection. So normally what I recommend is taking it in 3 steps instead of just 2. The first thing I personally would do is graph it with just A and B impacting the graph, which is what we've been doing. The second step, I probably think it would be easiest to do the reflection first. And then the third step would be go ahead and move it with left or right if you have an H value, or up or down if you have a K value. So you have 3 steps now instead of just 2. For example, if I take a look at y equals negative sine pi of x minus 2 plus 3, the first thing that I'm going to do is graph y equals sine of pi x. So it's basically the exact same thing, but I'm removing the reflection, the h value, the k value. I'm saving those for later. So I'm just looking at a, which is 1, disregarding the negative, and b, which is pi. So if a is 1, that means the amplitude is 1. And if b is pi, that means the period is 2 pi over pi, or that's 2. I know so far we've just been doing it with radians, but I wanted to show you it doesn't have to be radians every time. And it's still the same setup. So the full period length is 2. This first tally mark is going to be 1/4 times 2, which is 2 over 4, 1/2. The second is half of 2, which is just 1. And then the third is 3/4 of 2, which is 6 over 4, or 3/2. The amplitude, once again, was 1, so I'm just going to use a scale of 1. Now, it was a sine function, so that does impact the pattern. We start at the origin, up to a max, x-intercept, down to a min, x-intercept. So it should look, sorry, this is a little off. Let me fix that. So it should look something like this. That's step 1. Step 2 would be the reflection. Simple enough. When we reflect about the x-axis, you can write that if you like, the x-intercepts stay exactly where they are, but the maxes become mins and the mins become maxes. So I have a point here. At 1/2, instead of going up 1, I'm going to go down 1. At 1, it stays the same. At 3/2, instead of going down 1, we go up 1. And then at number 2, it stays. So this green graph is my graph with the reflection. And now, notice how I'm using different colors because I'm trying to make this as easy to read as possible. I'm going to do step 3. And step 3 says we need to do our reflection, or excuse me, our transformations with h and k. So h is a positive 2, meaning I'm going to move right 2, and k is a positive 3, which means I'm going up 3. So I'm going to take each point, make sure you're looking at the green graph, the graph that's reflected, and move it right 2, up 3. So I'm going to take this point, move it right 2, which is 4 tally marks, and then up 3. 1, 2, here, let me extend this. 1, 2, 3, 1, 2, 3, 4. So again, I'm starting at 0, 0. I'm moving it right 2, and then up 3. Okay, starting at 1/2, -1, I'm going to move it right 2, which would move it right here, and then up 3, so 1, 2, 3. Next, at 1, 0, I'm going to move it right 2. So 1, 2, and then up 3, which is right about here. At 3/2, 1, I'm going to move this point right here, right 2, so 1, 2, and then up 3, which is right about there. And last one, at the point 2, 0, I'm going to move it right 2 and up 3. Okay, so it should look something like this. So now if I ask you what the domain and range would be, domain's always all real numbers, and the range is going to oscillate between our min and our max. So our min is now at 2, and then our max is now at 4. I also want to point out that before the line, the center line was the x-axis. Now the center line is y=3. So that means that the k value impacts the center line of our trig function.